So what I want to do today is pretty easy. So I want to share with you the results from last Friday. Give me a second here. The results from last Friday last Thursday when we took the little quiz thingy, and then people who didn't take it, I'm going to ask them to take it today. So let me just show you how we did. All right, wrong problem. Wrong one. All right, here we go. All right, so ideally, I did not realize that you guys had more than one attempt. So some of you guys took it more than one time, which is fine, but it doesn't help me as much in knowing what questions we missed the most. But I can look at this and see. So here are the 5 questions. So the question about the graph was the most missed question. And that makes sense because I gave you some video notes on graphs, but I didn't really tell you how to read them. So we're going to do that today. Okay. The next most missed question was the one about the different type of velocities. So constant velocity, average velocity, and instantaneous velocity. So we'll talk about those today. And then you guys did pretty good on most people did pretty good on the speed question, scalar versus vector. Look, 81%, that's really good. And then distance versus displacement, you guys did pretty good on that too. That's 87% of the people got that one right. So that's really, really good. So what we're gonna do is today, we're gonna talk a little bit more about the graphs, okay? And then you're gonna so this one only counted for 5 points, okay? So I'm gonna give you another one today that is very similar, that counts for more points, because now, hopefully when we take it the second time, we'll do even better, okay? So if you are in there's a folder that says velocity and review. So if you go to 1D motion on Schoology, and I'm just gonna show you, I'm gonna work through it on my iPad, but I think I've said this before, but you definitely want some type of paper or notebook just for this class. So typically if we were in school, I would help you with organization and keeping up with due dates, but it's kind of hard to do that on a computer. But you need something very nice that is just for physics. So whether it's a notepad or like a binder or just a little book or something that's just for physics. That way, you're not like looking through your math folder or your math homework or your English trying to find your physics stuff, okay? All right, so what I'm gonna be in is in this folder right here that says velocity and review. I need to change the dates on that, but we're still in this folder. Okay, once I go in there, today what we're gonna do, we just went over the results from this, okay? So today I'm gonna be working on this sheet right here, okay? And then at the end of class, everybody's gonna work on these problems. Now, if you haven't done these problems, I do want you to do those first, okay? But in just a second. So you're gonna open this up and it's gonna look like this. We're gonna talk about graphing today. So you do want some paper and a pencil, and if you have a calculator, whether it's something kind of fancy like this or even fancier, or like this is super simple, right? Or your cell phone, you do need a calculator today, okay? All right, so you should see something that looks like this, okay? And we're gonna talk about how to read this graph, okay? And then in a second, I'm gonna switch to my iPad so I can write, so we can answer some questions, okay? And then we'll work on the quiz. All right, so this is in 1D motion. So if you go, there's a couple of different ways you can do it. If you are just on the Schoology page, if you're on this Schoology page, you can just click today's lesson and it's gonna take you into this folder, and this is where we are, and then it's right here. So the classroom just kind of saves you clicks. Now, if you're going through the folders, you're gonna go So this says today's lesson if you want to go that way, or you can come down, go to 1D motion, click that. Come in here, go to velocity and review, click that. And then distance time graph practice. It says 2016. It still works in 2020. It's cool. All right, and so we're right here, okay. So it looks like this. All right, a couple questions to start. First question is, could someone please tell me what is on the x-axis? What's on the x-axis?
Time.
Time, very nice, Joao. Yes, time is on the x-axis. And then on the y-axis, we have distance in kilometers or kilometers, if you say it that way, okay? Now, I want you to always pay attention to what's on your axes, because later on this week or next week, we're gonna have graphs that look the same, but instead of distance, it may say something else, and that makes it a different graph, okay? But anytime you have distance and time, what are we usually talking about when we talk about distance and time? What are we usually calculating?
How far, like
like miles per hour.
Yes.
How far you're traveling within a given time.
Which measures what? What's one word? Starts with an S.
speed.
Speed, there we go. So this is what we call a speed graph, okay? All right, so let's make sure we know how to read a graph first, and then we'll go into some questions. All right, first question. How about, Eric, if after 2 minutes, could you tell me how far the bus had traveled, the school bus had traveled after 2 minutes?
It has traveled 6 kilometers.
Very nice. All right, so I asked Eric how far the bus had traveled after 2 minutes. So I came over to 2 minutes right here, and I went up to where the dot is. And if I go over, that tells me I traveled 6 kilometers. Everyone see how we did that? Or anyone not see how we did that? I guess I should ask it that way. That'd be easier. Okay. All right. So, Sarah, how about, could you tell me, could you tell me at 7 minutes how far the bus had traveled at 7 minutes?
Like 13 kilometers.
Very nice. So she said like 13 kilometers. So if we notice, we came over to the 7, okay? She went all the way up until she hit the dot. And this dot is in between 12 and 14. Well, 13 is in between 12 and 14. So this is 13 kilometers, okay? All right, Ladarian, can you tell me how long it took, how many minutes did it take the bus to travel 16 kilometers? How long did it take the bus to travel 16 kilometers? And he's not even there. Okay. What'd you say, Allison?
8.
Very nice. 8 minutes. Okay. At 16 kilometers, it had traveled. Here's my dot. Now I can go down. 8 minutes. Took 8 minutes. Very nice. Okay. So now let's move on. So anybody have questions about how to read the little dots where they are? Yes, Leo.
I do.
Okay. So Leo, let's say if I asked you, after 3 minutes, okay, so can you find 3 minutes on my graph? Just tell me when you see it.
There.
So yes, so you see the minutes down here?
Yeah.
Okay, so at 3 minutes, if I want to know how far it traveled, I'm going to go up until I hit the dot. Okay, here's the dot. All right, now, if you go over this way, can you tell me what number you think this would line up with?
9.
9, exactly. So this traveled, in 3 minutes, it traveled 9 kilometers, okay? All right, so this first question says, at what time was the school bus stopped? Now that means he wasn't moving, okay? And if you're not moving, is your distance changing? No, it's not, okay? So where do we think the bus is not moving? Yes, Leo. Are you still raising your hand?
12 minutes.
Say again, Pamela?
12.
Yes, so exactly. Okay, so now we just have to look at, so Pamela said at 12, it stopped moving, right? So it's just 12 here, it's 12 here, and it's 12 here. So that's right. It's not moving right here. So wherever the line is flat, it's not moving. Now the question is, this says from, oops, excuse me, from what minute to what minute was it not moving? Yes, Leo.
Can you explain the thing that you explained before?
Yes, Esther. Say it again, Leo.
Could you explain it again?
Yes. So if the bus isn't moving, right? So right here, just pretend this is the bus, all right? So let's say this little hand is a little bus. So it's like, the bus is moving, it's moving, it's moving, it's moving up, okay? Because this distance over here is changing, okay? So when you get up here, is the bus still moving up?
No.
No, it's being still. So there's time is passing right here, but he's not increasing in distance. He's not going up any kind of way. So right here, the bus is being still. And then I was asking, from what minute to what minute was the bus being still? And Esther, what did you say?
Oh, 4.
4 to 6.
Yes, exactly. 4 to 6. So from 4 minutes, okay, so here's the 4. From 4 minutes all the way to 6 minutes, the bus is not moving. Okay, everybody see that? Bus is not moving.
Yeah.
Yes.
Good. All right. So then the next question says, at what time was the school bus traveling at a steady speed? So again, this one was 4 to 6 minutes. All right. So a steady speed means
From 0 to 4.
it is increasing, okay? It's increasing, and it's not like a weird increase. It's just a very nice, steady increase, okay? So Esther said, if you look at it right here, from 0 to 4, it's just a nice, steady increase. So right here, the bus is traveling at a steady speed, okay? We're gonna skip number 3 for now. All right, so we wanna know what was, I'm gonna minimize this just a little bit. All right, still pretty big, hopefully you can see it. All right, so,
Steady speed?
say again?
Well, what do you mean by steady speed?
Steady speed means I'm moving, but I'm not like slowing down and speeding up. Like I'm not going, like I'm moving. I'm moving, I'm driving down the road. My foot is on the gas pedal and I'm not like coming off the gas or pressing the gas any harder. My speed is consistent. It's not changing. So like if you are driving 30 miles per hour, you're driving 30 miles per hour, not like 30 and then 25 and then 35 and then 30 and then 25. You're just 30 miles per hour the whole way. It means to not change.
Is that on the graph?
Yes, right here, and I'll show you, and I'll tell you how we know this is true. Right here, see how this line is just kind of straight? It's increasing, but it's straight. That means a steady speed. Right here, look at this part of the line. This part is not moving, so he's not moving at all. And this part right here, it's not quite straight. It's kind of like got a little curve right here, a little dip right there. This is not, he's getting faster because the line is getting, it's going from this kind of like this. Right there, he's accelerating. Okay. All right. Carla, could you look at this graph and tell me what was the total distance the bus traveled? How far did he get?
20 kilometers.
Very nice. He traveled 20 kilometers or kilometers. And then Kevin, can you tell us how long the bus traveled, like in minutes?
9 minutes.
9 minutes. Very good. All right, here comes the math. If you don't have your pencil out or paper, make sure you do, okay? And I'm gonna switch my screens here so that I can show you what I'm doing. All right, I'm gonna stop sharing on here and I'm gonna share from here. All right, here we go. So, does anybody remember what does it mean if you take an average? What does that mean? How do you get the average typically, just in general?
You add up all the okay, so you would basically you add up how many numbers you have, I guess,
Mhm.
and then you just divide it by how many numbers there were.
Very nice, good. All right, so we're gonna do the same thing. On this one, they're asking for average speed, okay? What's the two things I need to figure out how to solve for speed? What's the two things I need?
You need the total distance and the total time.
Very nice, I need distance and time. So if you remember, and I'll zoom back in, I'm gonna zoom in for now and then I'll move back to the graph. All right, so if I want the total average speed, Garrett said it is distance, and then we divide that by the time. Okay,
Miss Payton, you had said that there was two more formulas for when we would do this.
yes, and we'll get to it. So the quiz we took on Thursday lets me know what we need to review before we move on. So that's why we're going to do this, and then we'll move on probably on Thursday.
Okay.
Okay. All right. So here, we're looking for the average speed right here. So remember Garrett said that's like the total. So total distance divided by total time. Now, if I drive to Florida right now, okay, I'm probably going to hit traffic in downtown, which means I have to slow down. And then I'm going to get south of the city and it's probably going to be pretty clear so then I can speed up, okay? That's instantaneous speed. Instantaneous sounds like what word? What shorter word? Instant, okay? So instantaneous speed is like what your speedometer reads, okay? So maybe I'm going 80, then I speed up to 82, and I slow down to 75. Average speed is saying, hey, I went to Florida, it's 300 miles away. It took me 5 hours to get there. I'm just gonna divide those two. So that's what we're gonna do right here. If we wanna know the average speed of the bus wasn't going the same speed the whole time, right? So if I pretend that this highlighter is the bus, first he was kind of increasing in speed. He's just kind of driving steady. Then he must have stopped for a bathroom break, okay, or pulled over. Then he starts speeding up right here, okay? So his speed was changing the whole time. But his average speed is gonna be how far he traveled, okay, divided by how long it took him to get there. And somebody, I think, Allison told us he traveled, what was the total amount that Allison said he traveled? Anybody remember?
20 kilometers.
20 kilometers, right? And then Kevin said the total time that the bus traveled was how long?
9 minutes.
9 minutes. All right, so that's what we're gonna do to get the average. So here, you're gonna need your calculator. So the distance, total distance that he traveled was 20 kilometers. So we're gonna do 20 km. And then the total time he traveled was 9 minutes. So 20, oops, excuse me, 20 kilometers divided by 9 minutes. Okay. Somebody tell me what they get when they divide 20.
2.2.
2.2, okay? Leo says 2.2. 2.2, and we also need a unit. So is this miles per hours, meters per second? What's my unit on this one? Ladarian, can you tell me my unit for this? 2.2 what? How fast were they going?
9.
I'm looking
I'm
for,
literally over here looking so confused because I don't know what to. I'm so
Because
confused.
you're not listening.
I am
You're not
listening. I just don't know what.
You
I don't know
over
what the miles per hour.
there laughing.
She asked me. I'm laughing because I'm
It's
confused.
the
And somebody
seconds.
called. It's because somebody walked in my
It's
room and called me
seconds,
stupid.
right?
is it seconds? What did we see over here? Ricky, what
Oh,
is
it's minutes.
very nice. So it's kilometers per minute. Kilometers per minute. Yes. Kilometers per minute. Very nice. Okay. All right. Here's where you really, if you haven't been paying attention, here's where you really need to pay attention. Yes, Leo.
What did you mean by unit?
Unit is just saying, like I said, 2.2, but it's like 2.2 what? Is it apples, oranges, miles, whatever. And the unit is right here. So we took a kilometer and then we divided it by a minute. So I just wrote the same thing right here. It's just saying what we're measuring. Does that make sense? We measured 20 kilometers in 9 minutes. So this is kilometers divided by a minute. And now as we do more, it'll make more sense. All right. If you haven't been paying attention, you haven't been writing, here is the time where you need to write, okay? All right, here we go. This says calculate the speed from 0 to 4 minutes. All right, here's the new thing. If we are calculating the speed from on a certain part of the graph, okay, we have to use slope. Okay, we have to use slope. And I'll explain how you get slope. If you don't know that word, I'll explain what I mean. It's basically how slanted the line is, okay? And I'm gonna show you how to calculate that, okay? So we're still gonna do speed, okay? And speed is still distance divided by time, all right? But now, because they want to know it just for 0 to 4 minutes, we have to use slope, okay? So this is called slope. All right. When we see these little dots on the graph, they have an address, okay? It's kind of like, what's your house address, okay? So for instance, when I look at this dot right here, I can give it an address by saying what the address is always X and Y, what the X one is and what the Y one is. All right, so if I look at this dot right here, what number is it at on the X axis?
0.
Very nice. It is at 0, okay? And the x-axis is time, so that's just like time down here. So I'm gonna write that in green, okay? So I'm gonna write a 0 right here, okay? All right, on the y-axis, okay, on the y-axis, what number is it at?
0.
It's also at 0, so I'm gonna do a 0 here too, all right? So that is for at 0 minutes. Now I'm gonna go all the way up to 4 minutes, okay? So this is me going over to, here's 4 minutes. I'm gonna go up to the dot, which is right here. And I'm gonna find the address for that dot, okay? All right, Leo, if you're looking at that dot, okay, and I wanna do the address, Could you tell me what number, remember x-axis is going this way, y-axis is going this way. Can you tell me what number is at on the x-axis? This is x.
Five.
This dot right here, if I come down, what number do you think is sitting at?
Oh, 4.
4. All right, great. So I'm going to put a 4 right here. Okay. And then let's see. David, what number is this at on the y-axis?
12.
12. Very nice. So I'm going to put a 12 right here. All right. So now we have the address for the 2. So here is, please, please, please make sure you're writing this if you don't know how to do this yet. Okay. So I'm going to come back down here. I'm going to try to, all right. So when we do like number 7, what we're working on right now, here's how we have to calculate it. We have to say the second y minus the first y, and we divide that by, and I'm going to go through and show you how to do it, the second x minus the first x, okay? So get that down, and then I'll show you how to do it. All right, so let's look at this. So the second y would be, okay, so remember when we're writing this, I'll write it again really big. When we write these addresses, it's always x and then y, okay? Everybody with me? X and then y. So down here, this first one right here, this is the first x and the first y. This is the second x and the second y, okay? So this is x2, y2, this is x1 and y1, all right? So now we're just gonna plug these numbers in, okay? So y2, can somebody tell me what y2 is?
12.
Well, very nice. How about y1, anybody?
0.
0, very nice. All right, divided by x2. What's x2?
4.
4. And x1?
0.
0. Very nice. So that leaves us with 12 minus 0, which is just 12. And then that's divided by 4 minus 0, which is 4, correct? Did I do something wrong? Let me make sure I'm doing this right. That should be right, yes? Any questions thus far before I finish this? Okay, so 12 minus 4, remember this 12 was in kilometers, this 4 was minutes, okay? If I divide those, I get 3. Everybody agree with that? And this is kilometers per minute. That's the speed that this bus was going from 0 to 4 minutes, okay? They won't always be pretty numbers like that. Sometimes they'll have decimals. All right, so you do have a quiz, but I wanna make sure we know how to do this. So I'm gonna leave this up on the screen for a second, okay? Make sure you got everything down. And then the next question says, what is the speed from 6 to 9 minutes? From 6 to 9 minutes, okay? So I'm gonna zoom, I'm gonna leave this here for just a second, and then I'm gonna zoom in on the graph, and I want you to do the one from 6 to 9 minutes, and I'm gonna put a Mentimeter in the chat, and I want you to write your answer on the Mentimeter. Yes, Leo?
Should we write this on a paper?
Yes, you should be taking notes and writing this on paper, yes. Okay. So I'm going to put a Mentimeter in the chat. Okay, after you work it out. So now I'm gonna zoom in so you can see it. Okay, so now that you got that, so I wanna know what is it, and I'm gonna erase this. All right, so now I'm looking from the speed from 6 to 9 minutes. I wanna know what that speed is from 6 to 9 minutes, okay? I'll give you a couple minutes to work on that. Okay. And then once you get your answer, go put in the Mentimeter. And I want everybody to put an answer in there because if not, I can't see if we need to do more practice.
Should we include the 2 zeros too?
If you get that's, well, it's just from 6 to 9. So the last time we did 0 to 4 minutes. This time we're doing 6 to 9 minutes. So make sure you adjust it. So this time we're just doing from here to here. So you may have new X's and Y's. I'll give some of you guys a hint. So this should be an X and a Y number. This should be your X1 and Y1. And this should be your X2, Y2. And then remember the equation was Y2 minus Y1 divided by X2 minus X1. All right. Getting some answers coming in. All right, let's start seeing what we got for answers. Let's see. Give me 1 second. All right, here is what I'm getting. So I want, let's see if,
Wait, we're supposed to divide after the numbers, right?
say again?
We're supposed to divide after we get the numbers.
Yes, yes.
Dang it. I forgot to divide.
All right, here we go. This is what we're getting, all right? So we're getting, some of us are getting, so let me see if, all right, so the 8 divided by 3, let me look. Let me see if it's just people not, so let's see. 20, there we go. Oh, I see. Okay, so yes, so when you get, for those of you who are getting the 8 divided by 3, I want you to actually divide those numbers, okay? So 8 over 3 means you need to divide those. So technically this is correct, but you need to divide this. So 8 divided by 3 would give you this 2.66 or 2.667 or 2.7. These are all correct, okay? The 0.375, I'll have to look to see. You flipped it, okay? So you put, if you got the 0.375, you put your X's on top instead of your Y's. So instead of 8 divided by 3, you did 3 divided by 8, okay? So we need to, that's all you have to do. And then we want to make sure, thank you very much to these people who put the correct units, okay? So this one is almost good. You need kilometers per minute, okay? So this is per minute, per minute, per minute, good. And these just need units, okay? Now, I wouldn't take 4, but I would take 3. Because 2.6, if you round that, it is close to 3, okay? All right, so let's see. Was there anything else? Any questions on that? Okay, all right, so really quickly, I have been messaging a couple of people. I don't know if I messaged everyone yet to stick around after class. I got a couple of other people I need to message, but what I want you got about 4 minutes. So let me just show you in your folder again what you should be working on. Let me share screen one more time. So if you have not, so I'm going to click today's lesson. Okay, I'm going to click today's lesson right here. Okay, and it's going to take me directly here. If you did not do this last Thursday with the rest of us, I'm going to fix that right now so you can get that done today. Okay, so this is 4B. This needs to be done today. Okay, if you did do this already, okay, these velocity practice problems are very, very, very similar to this one. It is worth more points because now we've gone over it twice. Okay, so this is what I want you to do by, I'm going to change the due date. I have it set for today. I want you to try to get it done today. Let's just say the 3rd. I want you to try to get it done by today and enable save changes. There we go. Okay.